And it's Friday, the 8th, and we're going to talk about the derivative of e to the x and integrals involving e to the x, but you already know that, right? What's the derivative of e to the x? I told you this before. Nope.
No.
Before yesterday.
Oh, no, it's e to the u.
The derivative of e to the x is e to the x, right? But did we ever prove it?
No.
Now we can. All right, here we go.
Mr. Garcia,
What?
can we please go over the last thing we did yesterday?
The last thing we did yesterday? Real quick. Okay, yeah.
Yeah, I didn't really understand it, so it's on in the last.
Okay, all right. Real quick from yesterday. What's the derivative of the tangent function? Okay. Well, remember that the tangent function can be written as sine over cosine. Okay. And we have a tool now to differentiate quotients like this, right? Not the derivative, sorry, the integral. We know the derivative. The derivative of tangent is secant squared. Now we have this new tool that helps us integrate quotients like this, right? In other words, who's u? Who's u? U is? Well, think of, hint, it's going to involve ln. Remember that you know how to integrate 1 over u du. That gives you ln u. The integral of 1 over x dx is ln x, right? So if I'm using that pattern, u is the bottom. So if u is cosine, who's du? Negative sine x dx. Well, that's the numerator, isn't it? Almost. Sine x dx is replaced by what? How do you get rid of this? Put it over here. Divide both sides by -1, multiply by both sides by -1, whatever. So this is really 1 over u times negative du. How do you integrate 1 over u du? Ln u. So it's negative ln absolute u. Okay, remember when you integrate 1 over u du, you get ln absolute u, because sometimes you get negative arguments. You don't want that in an ln. Now, that's fine, but what's in front here? A -1. Remember what logs do? They take exponents, put them in front. What if you put it back in? 1 over cosine. And doesn't 1 over cosine have a name? They're the same thing, but some people like to use this instead. So, probably in Bob, you'll probably see stuff like this. Okay? Same thing with cotan. Want to do cotan?
Yeah.
The integral of the tangent is ln of the secant. What's the integral of the cotan? Well, let's see. Integral of the cotan, whoops. By the way, I should let you know that you guys are no longer the YouTubers.
Oh, yeah.
Yeah, I switched up because first period I have to end way early to render the video before the teacher for second period comes in. So I figured let that be the YouTube class, because then I can keep it short. And you guys are going to record the whole class.
Oh, great.
Okay? So you're going to be the FDPers. Okay? Yeah. Huh? Oh, dang it. Well, not today. No, I can make this up to 60 minutes. Damn it, I forgot. Oh, well. Yeah, I have to log in first. I thought I did. Anyhow, all right, today's 15 minutes, I guess. But from now on, it'll probably be more like 30. You know, okay. So, again, cotan can be rewritten. What do you think it is? If tangent is sine over cosine, cotan is cosine over sine, because cosine is just the reciprocal, multiplicative inverse of tan. Now who's u? Sine. If u is sine, du is cosine x dx. So guess what? This is du already. It's not even negative du. It's not du over 2, it's just du over u already. How do you integrate 1 over u du? Ln absolute u. U is sine. If you want to be crazy, is this the same thing?
Yeah, I don't want to do that.
Some people like secants and cosecants better than sines and cosines. You know, they just do. I don't know why. There's no real good reason. I like this one only because there's no negative in front. It's easy to remember. I like this one for the same reason. But there's really no preference. All right, so that's just a new rule we should keep in mind, okay? All right, so can I move on to today's topic?
I guess so.
All right,
I found this yesterday. I'm gonna steal it.
good.
I found it in here.
You found it in here? That's right, I throw it out if I find it, because I don't keep bit up pens with people's germs and swine flu all over it.
Well, we're getting the vaccination, so you don't have to.
Okay, I'm not worried then, okay. All right, now, here's today's topic. If y is e to the x, what's y prime? Now, we already talked about this, it's e to the x, but we never proved it, we just sort of threw it at you, right? And we may have estimated with the quotient rule, with the difference quotient and convergence tables and maybe graphically whatnot, but can we show this exactly true, that the derivative is e to the x? Hint, 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 we know this new thing called logarithmic differentiation. What if you take the log of both sides? What do you get? What if you take the ln of both sides? You get ln of y equals x. That's it. Well, ln e is 1, right? Okay. Now, what if you differentiate that instead? I'm still looking for dy dx, right? Y prime, I'm looking for dy dx. What if you differentiate this?
That's it.
This is ln y.
Oh, I thought it was e.
Nope. What if you differentiate this implicitly with respect to x, where y is a function in x? Okay, so ln y differentiates as? You forgot already? Remember that the integral of 1 over x dx is the ln the absolute value of x, right? So the derivative of ln x is 1 over x, right? So what's the derivative of ln u?
Oh, that's a u?
Well, it's a y, but it's like a u. It's not an x, right?
Is it 1 over y?
1 over y dy dx. 1 over y, y prime, right? Remember implicit. Equals, what's the derivative of this? 1, just 1. Now remember, the question was, what's y prime? That's this. How do you get this alone? Multiply by y. So, dy dx is y. But what's y? It's e to the x. Okay? So, if y is e to the x, dy dx is e to the x. It's its own derivative. It's the only function that acts like that. What?
That's my favorite.
Alrighty, so let's summarize that in terms of the chain rule. If I'm taking the derivative with respect to x of e to the u, I get e to the u du dx. If I'm integrating e to the u du, I get e to the u plus c. These two rules you should know. And I didn't do that. Right, very important. Yay. Alrighty? So let's practice these rules. Oh, where did it go? Yeah, there was a plus C in there. There was a plus C somewhere. Okay. All right, so let's practice this up. Here's some questions regarding this. What if I want y? What if I want the derivative of y, which is 2e to the x? What do you say y prime or dy dx is? What do you say? 2e to the x. That's it. That's all it is. Okay. What if y is e to the 2x over 3? In other words, e to the u. What's y prime? E to the u du, right? That's what you said, right? Okay. What if y is x times e squared minus e to the x? What's y prime? Any ideas? What's the derivative of this first term? And don't say product rule. Why not? What's the answer? Nope. I'm not hearing it. This is the same question. Are you ready? Same kind of question. What's the derivative of 2 times x? 2. This is a constant. What's the derivative of e to the 2 times x? E to the 2. It's just a number. Okay? The wrong way to do this, in that it's too much work, why do it, but it works, is the product rule. First times the derivative of the second plus the second times the derivative of the first. This is 0. This is e squared, right? The problem is when people do the product rule on this, they treat this as if it's not a constant. They do crazy stuff like first times the derivative of the second plus the second times the derivative of the first, and get something really weird. Wrong. So I wouldn't do product rule and stuff like this. That's silly. All right, so e squared minus what? E to the x. So this is okay, but it's just too much work for nothing to get this, right? I wouldn't do this either. This is wrong. People do this. I'm just clue you in to avoid that. All right, those are some derivatives. How about some integrals involving this stuff? Can I move on? You don't care because you got 15 pages waiting right here. All right, here we go. The definite integral from 1 to e squared of 1 over x dx. What's the antiderivative of 1 over x dx? ln absolute x. Sometimes there's negatives. We can get rid of it. Don't forget the absolute value. In this case, the absolute value doesn't matter because I'm plugging positive numbers from 1 to e squared, but whatever. So plug it in. ln absolute e squared minus ln absolute 1. ln of 1 is 0, right? What's ln of e squared? Well, what does ln do to exponents?
Oh,
2 ln e. And what's ln e? 1. It's times 2, right. Okay? So that area is 2. Okay. Any questions how we arrived at that? Okay, goody. How about this one? What's a definite integral from ln2 to ln3 of e to the x dx? Well, the antiderivative of e to the x dx is e to the x. So plug in ln3 and plug in ln2 and subtract. But what's e to the ln of 3? 3. And what's e to the ln of 2? 2. So what do you got? 1. Well, because remember, e to the x and ln of x are inverse functions. They cancel each other out. Like square and square root. Okay, these just cancel. Okay.
So e to the ln x is x.
Yeah, exactly. They're inverse functions.
What if you have ln x to the e?
Same thing. Yep. All right, what about this one? Can I go?
Yeah.
All right. The definite integral from 0 to 1 of 1 plus e to the x times e to the x dx. Now, how do you anti-differentiate that analytically? I'll give you a hint. It's a u. You can do it by u sub or you can do it by distribution.
Let's distribute.
Well, I want to do a u sub.
Okay, let's do
Who's u? 1 plus e to the x. Why? Because if u is 1 plus e to the x, du is e to the x dx, and so it's a straight u sub. This is already u du. How do you integrate u du? Just u squared over 2, just like x dx. How do you integrate x dx? X squared over 2, right? All right, so it's u squared over 2, but who's u? 1 plus e to the x. Evaluated from 0 to 1. Okay, so let's plug in. You get 1 plus e to the 1 over 2, the numerator squared, minus 1 plus e to the 0 over 2, and the numerator is squared. All right, so let's see. Well, I don't know how much you can simplify this. E to the 0 is 1, and 1 plus 1 is 2, and 2 squared is 4. And 1 plus e squared is, they have a common denominator. I guess you could write it like that. What if we FOIL it out? Does that simplify it all? FOIL this out. 1 plus 2e plus e squared minus 4 over 2. Well, what about the 1 and the 4? All right, so I'm going to say it's e. I got to go up? What part? There? Okay. I'm going to write it this way. E squared plus 2e minus 3 over 2. And you can get a decimal equivalent from the calculator if you like, but that's an exact answer. I'm done.